Alles gut?
Alles gut.
Genau, ich habe den WhatsApp noch was geschrieben. Wenn du mir...
Ich soll dir das mal gerade schicken?
Ja, und bitte per WhatsApp tatsächlich.
Ja.
Dankeschön. To the final presentations of this year's Makeathon. Please everyone find a seat, and if you haven't got any free seat left, we have the live streaming upstairs. We might close the door upstairs because there's some delay in the audio so people don't get confused. How are you doing? All right, so I think it was some quite intense days. I'm really impressed what you did in those days, so I'm looking forward to what you're presenting here. So today the stage is yours. Before we start with the presentations, I want to say, or give you some impressions on what happened the last days. So we had our media team, of course, and they did some photos, and let's take a look at some of those. So we started on Wednesday, we were here, everyone arriving, what's going to happen. You gathered together, put some teams, and brainstormed what you want to do over the next days, and then prototyping, and today those are finished. And let's take maybe a look at some of those pictures. I think we need to have the technicians switch the video input. Is it, yes, okay. So hopefully you have some pictures soon. So who was at the carnival yesterday? Hands up. Are you still awake? Okay, and you still made it. So work hard, play hard, no? Really like it. So still no pictures? Wow, what else is there to say? Okay, let's say hello to Rainer. I'm sorry, you have to be our you have to give us some time.
Okay, I'll be the Pausenclown.
Let's be the Pausenclown together. So say hello to Rainer. So at the end of the day, it's his fault that we are all here, that we can be here. So Rainer, a big thank you that you put me here 10 years ago, and yeah, thanks for this journey.
Thank you. So, okay, guys and girls, yes. Thank you so much that you all are here. Well, we have to thank as well to Raul. Yeah, Raul, venga aquí. Raul Garcia Brink, he knows as well as German, but he never dares to speak. Yeah? He was how many years in the Colegio Alemán? 10 years? 10 or 12. 10 years old, yeah. Well, he understands. 10 or 12. He understands perfect as well German, and it was very funny because this was when we ran into each other the first time. It was very funny because actually Jonas was at that time a student, and he had a friend there at the Infika where we were the last few years. Yeah. Well, and he talked with this manager of the facility. Yeah. This room is always empty, we can use it. Yeah? And then we were there with these nice t-shirts, yeah? And then he came with a serious face and there is somebody who looks representative and a little bit angry. He wants to talk with you. It was him. Because he was responsible for the area, but he didn't have an idea what we're doing there. This was the first time that we ran into each other, and this was very nice. Yeah? And now I would like to hand over to you. Yeah? You are very keen on the things what we're doing, because the Smart Green Island, you call it Eco Island, and there will be soon a cool conference here on the island, and you're doing a lot of stuff. Yeah? And I always admire you at TikTok and Facebook and LinkedIn, that you're really pushing hard. And I think you can give us some insights what you're doing actually.
So yes, I'm half Dutch. Yes, my mother was Dutch, and so I'm half Dutch and I half Canarian. And but I studied in the German school, and yes, my family in Netherlands was not too. They were incompetence. Yes, football against Germany, and Germany was the competence of the Netherlands. Yes. And we are developing here in Gran Canaria different kind of projects, yes, in order to achieve, yes, a sustainable development here in the island, yes. And I think that we are the leaders in the Canary Island in this moment, and the 30% of the energy of the island, approximately, is renewable energy, and we are now waiting that we are constructing a hydro pump facility in the south of the island, the Salto de Chira, and with 200 megawatts, yes, and we hope that with this big storage project we can achieve 65% of renewable penetration in the island, yes, because we are not connected with mainland, and so we are energetically isolated, yes. We are not connected with another island also, so that it is very difficult, yes, to maintain the equilibrium, yes, in our energy system. And we are also developing in this moment, our government, I think that 35 PV projects, we are also developing many electric charging stations. We will, I hope that in 3 months we will inaugurate the number 100, so that our government has 100 charging stations through the whole island, yes? So that you go to any municipality in the coast or in the mountains, and you can find charging stations, yes, for electrical vehicles. And we are developing also innovation projects, very interesting. For example, here in the port of Las Palmas, I hope that the hydrolyzer is now here in Gran Canaria. We will have also green hydrogen here in the port of Las Palmas. And well, we develop also, we are now deciding where to drill, because we have also a geothermal project, very important, with a big budget, and we will do 3 drillings in the south of the island. We think that there is a resource inside, so that the drillings will be of 2.7 kilometers. Yes, very deep. Yes, and I hope that we will start with a public-private initiative. I hope that in 2 or 3 months we start to make these drillings in the south of the island, so that we are really committed with. We have many other kind of projects, also climate adaptation projects, many climate adaptation projects in this moment, and so that we work on mitigation, but we work also in adaptation, and also I was talking with Rainer, and I was saying to him that there are also many companies here in Gran Canaria that work in the circular economy. Yes, this is also the island that who has the leadership also in circular economy here in the Canary Islands. So we have many more projects, but I think that this is only a few examples, yes, of what we are doing here in Gran Canaria. Okay. So, thank you.
Thank you so much. Well, actually, I think when we met the first time 10 years ago, this was not existing, what you're talking, because at that time you were not responsible for these things. Now you're responsible for this thing, and therefore you're pushing hard. Yeah, really great, yeah, because 10 years ago, people ask me, and it's still when the TV comes here, they ask me, why you are here? Yeah? And then I always tell them, well, there's sun, there's wind. Yeah? If you dig deep, then there is something warm. Yeah? And therefore, there's, from my point of view as a German engineer, unlimited resources, and you have to use it. Yeah? And you understood it, and I always see in your posts that you fight with some persons who don't like to understand it. Yeah? There are a lot of them in this world. Yeah? And therefore a big applause to him, because he's really pushing hard. So, and then to congratulate as well Naira. Yeah? Actually, she's arrived together with me, especially the new idea with the cooking. Yeah. You want to say? I saw it in your eyes that you want to talk as well.
Okay. I only want to say thank you to everybody, and I know that some of them they are telling me that they are happy to be here in the museum. They are happy with food as well. Yeah. Yeah. Fine. Because it was a great challenge, so thank you, a special thank you for Wilhelmshaven, Wilhelmshaven School, because they did a great job, and a special thank you for the museum, for the team, you are gonna invite them, Thank you very much, Thank you to everybody.
Thank you, Nora. Yes, so we were very, very happy here to be in this wonderful place, and we were happily welcomed by Arancha. Please come here, give her a big applause, because I think being at this place was really special. So, Arantxa, we really had a great time here in the museum. It's like a wonderful place to do this kind of event, and you were so welcoming and helped us for all the problems we had. So, thank you so much for having us. All right. I think we start with the presentations now. We can take a look at some pictures later. So, you know when your time is. You have the agenda in the Mattermost, I guess. We start with the responsible butt detection team, and please also, if you're the next team, make sure you also stay close already. So, warm applause for MV Tech team's responsible butt detection. Ja, also hat eine neue Batterie, kannst du mal versuchen.
Wir haben jemanden, der einen Laptop klicken wird, sonst
Dann,
super.
ja.
Yeah, so we basically dream about similar things. We all dream about beautiful beaches and maybe even also beautiful beach bodies. But sometimes our dreams, we get a wake-up call. Dreams aren't sometimes just dreams and not real. In this case, beautiful beaches are sometimes dirty. We humans destroy our nature with, in this specific case, with cigarette butts. What do you think, guys? How many cigarette butts do we as humans improperly throw away each year? Hands up, who's in favor of 1.5 billion? Worldwide. Improperly. Hands up for 20 billion. Okay, some more. Hands up for 4.5 trillion. Yeah. Yeah, in fact, it is 4.5 trillion improperly discarded cigarette butts each year. This number comes from WHO, so nothing made up here. But yeah, that's a huge problem, and that's exactly why we teamed up with the MVTech team to tackle this challenge and to build the beach body. What is the beach body? You can see it already made up here. We built a robot who can actually see and therefore collect cigarette butts. We consisted out of 4 teams, or we teamed up with 4 teams to make this huge challenge work. We basically have one team, my team, who were responsible for teaching the robot to see, the vision team. The next team was responsible for making sure the robot actually moves. The other team was responsible for collecting the rubbish. And the last team made sure we have some place to dispose the trash again when the robot is full. Here you can see the camera. We actually were responsible to teach the robots in a short time to recognize cigarette butts, which was quite a challenge. But we split the challenge up in 4 main cornerstones, 4 big milestones. First of all, we somehow have to gather large appropriate data sets, which, as you might imagine, consisted of a lot of different pictures of cigarette butts. Here you can see us taking tons of pictures with so in the end we had actually more than 2,500 data pieces that we fed our model with. The next step, we used those pictures to generate training material. Might you go back a slide? Here you can see us labeling those cigarette butts and therefore teaching the model what actually is a cigarette butt and what not, so it doesn't get confused with little stones or just maybe gum on the floor, which was quite a challenge. We had to do a lot of labeling there. And in the next step, we let the model learn. Here you can see the interface of the deep learning tool we used for MVTech. And in the end, we managed to achieve over 70% F1 score, which means the model is 70% sure or can recognize cigarette butts in a picture with 70% accuracy, which is, considering the time we had, a really successful score. And the last step was refinement, and we had to do a lot of review rounds to, actually made sure the robot in the end can see. On the left-hand side, you can see our first try run. There you can see the model only recognized one of those cigarette butts, and in the end, today morning, we managed to make it work in a really nice and efficient way. Here you can see the robot actually recognized each cigarette butt on the floor. So great success from our engineering team there. So now in the end, our robot can see and can recognize cigarette butts.
So the robot can see, but now he has to move. So we had actually two challenges. We want to move this robot and we want to connect the interfaces. So the second challenge is maybe more difficult than just moving. We start with much different steps just to define the problems, define the interfaces. So the first day we're just spending on defining interfaces, speech with the different groups. And then we start to make a location, say this is location, this is our area we tested. We actually tested outside to make it more difficult, because easy is easy. All right, we working on a moving strategy. So we say we have a bird camera and want to have a strategy where at what time he wants to move to which cigarette he starts with. And actually we finishing testing in this morning, so everything is done right now. Right, we have different components. So the bird view camera is up on the front, on the top of this area we define. We have the camera on this robot to spot cigarettes, and we have a overall communication in the Raspberry Pi. On the top, this Raspberry Pi makes the communication, comes together and navigates the robots. The bird's camera all time tracks the robots with a tracking system. So we use, can you go on the next page? So we used a tracking system, and to handle all the different interfaces, we use easy plug-and-play solutions. So we say it's not a problem. We had too much Arduinos. We just say just plug and play, bring it together, stick it together, and make it easy. So we have standardization, coordination transfer, and we move with MVTech, the MVTech software in Python, so it makes it much more easier for us to handle these problems. All right, this is the tracking system. We changed it a little bit just to have the position and the direction, and then we want to or can detect the position of the cigarette and can move the right way to the cigarette, as we say, maybe later in the video if it works. All right. So.
Now, our our team is responsible for this part. Our challenges is actually to correct the cigarettes mechanically and drop it into the bin. That's our challenges. And for it, we use some ideas. Then one of it is from this forklift, and one of it from this golf ball picker. Here we can see it. This brush will spin so that we can correct the cigarette into our shovel, and it will go up with these motors. And at the end, this brush will spin the another direction and deposit the cigarette. At the end, we made a cigarette launcher. When we correct the cigarette, then the cigarette goes up in the air, and when we deposit the cigarette, then it shoots into the bin. But yet too much power. But we learned a lot in this team. For example, working as a team, and we had a lot of pressures because of 3D printer. And also we had to think about a lot of the creative idea because we didn't have such a brush and also roll. So we used actually the roll for painting and also the weave.
I'm here representing the final part of the entire process of cleaning the cigarette butts, the depositing system. Our challenge was mostly finding out with the other teams how to make the card travel to our deposit system, because it's just basically a box, so we work with the navigation and the camera team to figure out in what ways we could move it, and finally we did it by an electromagnetic sensor. And we had a challenge of keeping track of how full it is, because you can keep filling it, but at some point it will get full. So as you can see on screen, here is our prototype. In the side where the wires are going, there's a distance sensor which will measure how far everything is, and if it's anything between the sensor and the end of the box, the light in the other box will light red. And all you need to work it is just a power bank. As a team, we were, of course, a bit late with writing in, which means we got this second-hand, basically. But still, we weren't that good in working with the hardware, working with an Arduino, so we learned a bunch of valuable skills during this, including communication between our teams and working together as a whole team.
All right, it's a big team, really big team. So we see a picture of our big team, the 4 groups in one picture. It was just beautiful. And I'm saying on the next slides, yeah, we see our solution, finally solution. So in the different steps, collecting and bringing to the box and drop off in the box. So actually, just this morning, it works. Let's see.
Video?
I don't see anything.
Video is not the best.
Okay, maybe we just skip it.
Oh, don't skip it.
All right, so we have a big group, so from many different universities of Germany and Netherlands, right? Yeah. From Netherlands, yes. So it was a cool team, and I just want to say thank you for everyone who made it possible that we come here together and have this challenge, especially.
Yeah, special thanks to Rainer, ICQ, Gerda Stiftung, and especially you guys. Come up here in the front, have your applause. Rainer, feel free to come here as well. But thank you guys. Thank you. Thank you. It was a special pleasure working with you guys. Thank you for keeping up with us and also teaching us a lot of stuff. Was great fun working here. Thank you, Rainer. Thank you for the organization team for hosting us here, keeping us warm and also not hungry. Yeah, thank you guys. And if you wanna see the robot alive, as the video somehow didn't work, we later on keep the robot at the front door, and you can come out and see it for yourself. Thank you.
So yeah, also from my side, guys from Invitec, we are so happy to have you here again this year. It's always fun working with you guys, and you do some really cool tech stuff, so thanks a lot, and I'm looking forward to what you're going to do in the future. Thank you, guys. All right, let's continue with the Myler teams. So up on stage is Team Myler. Welcome on stage.
Thank you so much.
Okay, then.
All right, good morning. I hope everyone's gotten their coffees in. So I'm here representing Team Myler. So our project was based on smart automation. Yep, so I'd like to introduce the team first. So I was leading and working on the presentations. Aditya was the project manager, working on CAD as well. Marlene, Matthias, Mert, Dennis, and Sina, they were basically the brain of the whole operation. Laura, Babel, and Daniel, so they were working on the mechanical stuff. They made all the cool stuff that we had in our robots. So the problem statements. So when we talk about waste handling, we only think about manual operations, right? So there's still a lot of scope for smart automation in that area. And then sometimes when the containers are not placed properly, there's alignment issues. And then there's a lot of, a lot of delays, processing times. So we thought of maybe why not implement something smart automation system so that we don't have to do it manually, we don't have to think about it. And anyways, waste is like rising every day. And since there is a lot of waste right now, we can just automate it. So that was basically a problem statement and a thought. Also, our sponsors had a step-by-step challenge level, which was easy for the growth development for the whole team. Yep.
Thank you. So I want to talk a bit about our solution. So we teamed up with the Myler Kipper guys, and we thought about generally just making this whole process autonomous. How we will use vision detection and smart navigation, so we can do like the maneuvering smart and also reliable, so we can do it over and over again and it works every time. Then we also need to do something about the efficiency, so the delays, like driving back and forth until the container fits and stuff. So that was also the smart vision that helped us with doing all that rearranging. And just generally, when we think about the containers, what do they contain? It's a lot of the time it's waste. So with this challenge, we also support the waste management. So here's now what actually our prototype looked like and is looking like right now. We have a video for you playing, hopefully, that shows how our vehicle is automatically detecting the container. We have those little markers you see at the front of the container, and those are Aruco markers. With the camera we put on the back of the truck, we could detect the container and those little markers. We could detect what kind of distance we have, what kind of angle we have to these markers and to the container, and then how we have to do the driving. And a little bit also to the driving, we had to do it on base level Python, so there was no big driving functions. We had base functions, but we needed to implement the steering and the driving and also operating the pump, how to do that with the correct level and the correct angle. So that was a big part of the challenge for the programming people, and we had a lot of just general mechanics for the camera placement and figuring out a stable power architecture for the microcontroller we used for this project. All right, so I want to talk a little bit about the teamwork. We split into different groups for better handling the specific problems, so programming, more mechanical things, and the 3D printing process. But I think our coolest moment was when we came back together and tried it out together, and it worked. So like the first lifting, the first recognition of the container, the first lifting process, we were pretty relieved, and it was amazing to do that together, even though we worked on different parts. And also huge shout out to the Myla Kipper guys for doing overtime and fixing the hydraulic system. Big thank you. So yeah, applause for you guys. Without your support, we could have managed that. And also, thank you to this event. Thank you, Rainer, that we could be here. Thank you for the presentation. And yeah.
Thank you, the team from Milo. Where are the Milo guys? Here, come on stage. So also for you from the team Milo, well, we heard it from your team. They were happy. We were also very happy to have you. So thank you so much for joining us as a sponsor this year. Give them a warm applause. All right. We continue with the teams from the Litter Puppies. Give them a warm applause.
Okay, hello and a warm welcome from us, the Litter Puppies. We basically made our own challenge under the premise of fetching the future, the AI-powered litter retrieval with a quadruped robot. First and foremost, we would like to thank our sponsors, of course, for this amazing event, and first and foremost, CircuMind, who were our main sponsors for this. In this presentation, I'm going to go over the problem and the idea that we had to solve it, then of course the solution and the concept, and lastly I'm going to introduce our team members to you. Just with the cigarette butts, it's the same with bottle caps. We all know the European Union just introduced this beautiful law that all the bottle caps are attached to the bottles now, but it's in the European Union, not worldwide. Still, bottle caps are one of the most common waste types, and they're difficult to recycle due to the plastic they're made of. They also are usually in rough terrain, because on the street you can sweep them up, but in the forest there isn't hardly going to be a sweeper there. And the humans won't pick it up, and wheels usually cannot get to forest or Sahara or similar, or the beaches. And lastly, we of course have the manual limit. We have way too many cabs, way too little time, and way too little personnel to actually pick them up. So our idea was to use the XGO dog robot. And it can navigate through rough terrain due to its 4 legs that we can see here in our prototype or even on the picture. We have the solution of requiring no human labor. It is fully automatic and walks towards the bottle cap, identifies it, and discards it. Thus, I would really like to show you our videos of how this works before I introduce you of what we did, so you already have a picture in your mind. And let's hope our videos work. Yes. So here you can see it identified the bottle cap, takes the bottle cap, sees that it has it, and discards it in its own waste bin. And here I wanted to show you the video that the robot sees. As you can see, it identified the bottle cap due to the green square that you could see in the picture. Then it picked it up, identified it, and discarded it. Now, to go over our solution and the concept, we have 3 main parts that we worked on in different teams. Namely, the machine vision department. Of course, the robot needs to see the movement and the gripping of the bottle cap. For the machine vision, we of course needed a data set in order to see the bottle caps essentially. The robot has a little camera mounted right under the gripper here, as you can maybe see, probably not. And we took a lot of pictures with this camera and then manually annotated it in order to train our YOLO V8 Nano model. YOLO essentially means you only look once, not you only live once, you know? You only look once. And it is very good at object detection, which is why we used it. We also added a dead zone filter, so the machine vision wouldn't identify bottle caps that are like in the upper third, because we need the bottle caps that it sees in front of it and not like 2 meters away. And we implemented the stability over 5 frames in order to reduce the level of misidentifications. Coming to the movement department, of course, the most important one, because you can see it, but you still need to get there. We implemented the motion behavior, of course, for the search state. I'm sorry, I slipped over my tongue. It tilts to the left, it tilts to the right in order to increase its own center of vision. Yes, sorry. We used MQTT for the motion interface, for the instant velocity commands. And lastly, we had a linear closed loop controller to approach the bottle cap, because just running towards it like a maniac won't help. We of course need to orient ourselves. Then when we are actually there, we go to the gripping. We have the motion behavior for the gripping state. As you can see, thank you. The robot has an integrated gripper, but we still needed to program the gripper to actually come forward and grip everything and then discard it in the back. As you can see, it bends down and then forward in order to grab the bottle cap, and then it would discard it. We then had a CAD model for the robot periphery, so it actually knows where it is, and a 3D modeling and, of course, printing of the waistband in the back. Yes, we added a tail because it is a dog and it's adorable. Now coming to my last point, introducing our team to you. Okay, so I'm fine. Don't show me something. We are a team of 10 people here, and the machine vision was made by Christina and myself. So we took the pictures, we annotated it, and then trained the model and everything else around it. We have the movement department containing Krian, Kilian, Jonathan, Alex, and Lucas. So yes, that was the biggest team. And last but not least, we have Friedemann, Leon, and Mostab for our gripping department. And Friedemann really carried our hardware department here because he was soldering so much and 3D printing and everything, because we also needed a lamp in order to increase the visibility of our camera. We did learn a lot about working together, thinking a lot, and generally we had a great experience. We utilized our own strengths, have made these departments on what we could do best, and we had a really great time at this Makeathon. So thank you for the organization, and this concludes my presentation. Thanks for listening.
Thank you very much. Thank you very much. Up next, can you hear me in the back? Okay, let's go like this. Up next on stage, Recyclable Fun. Give them a warm applause. Oh, you have some demo as well?
Already recycled.
Already recycled, okay. Put here the intercom.
Yeah, so welcome everyone. Thank you for being here. I would like to start my presentation by asking a question that I'm a little bit afraid to ask because you're mostly Austrians and German, but how many of you really knows how to sort their trash correctly? Yeah. I come from Egypt, so it's a little bit difficult for me. And I can't tell you how confusing it could be. So if I started saying it will take so long, so I will let him tell you. On the audio.
You don't? So maybe we have to increase the volume there. Is it possible? Let's try once more. And otherwise, you just have to do that. Okay.
I restarted. Yeah,
First day in Germany. Oh my God. Why are there so many bins? Whatever. 1 week in Germany. What is this? What? I have to sort the trash here? That's crazy. 1 month in Germany. Okay, metal here. Plastic also. Why is this so complicated? Who has time for this? I thought Germans are all about efficiency. 1 year in Germany. This is actually pretty smart. Sustainable. I like it. 5 years in Germany. Who put this plastic in the paper bin? Who was it? Well, someone's gotta tell them. 10 years in Germany. Again? Unbelievable. Those experts, they never learn. There you are. Ja, hallo? Erster das Ordnungsamt? Ich habe hier einen Wiederholungstäter. Ja, ein ganz böser Schlingel.
Yeah, so you can see how confusing it is. So we decided to think of a way to make it really fun for children and for actually every age group to learn how to sort their trash, especially for, of course, children from 6 to 11, also for international students who come to Europe and they are not familiar with the system. Also, it could be for adults who are still unfamiliar with this system. So to do this, we had to think really in an innovative way and to say, okay, maybe it's fun for children, but what about these adults? How could it be fun for them? And for that, we thought of how to make our product really modular and to streamline the development process in order to get all the components easily from, for example, Amazon or from any shop nearby. So for children, they are just going to play with it. They are going to enjoy it. For a little bit older children, they can develop it themselves. So the idea is how to make it DIY with fun. we can give some instructions on how to build it, and so on. So for adults, it could be a first step into programming and developing. It could be a really fun DIY night, and for children, of course, to enjoy it. We used an AI camera with a machine learning model that it's very lightweight and easy to train. All the design for the trash bins and for our component is made of recycled products, so basically the trash from this Makeathon actually. You can fit it completely within the original package, so no waste at all, and I think that was really innovative. This is the innovative part of the project. And now I want to show you how it works. Yes. Yeah, so this was Abiyu.
Try to drill again. Amazing! You're a superhero!
Yeah, I always get confused with these cans. I always throw them in the general trash, but it's actually plastic. I don't know how. And now the final thing is the learning part, so you can practice with the previous parts, but the learning part is actually a joker button where you can, if you are confused, you just show it to the camera and then it will teach you why to put it in this bin. Sorry, yeah. This one.
You have to think more.
Yeah, so now I learned this is paper. Yeah, so this is our amazing team. I really enjoyed working with them. It was an amazing project. I want to thank a lot the School of KPO. I hope I'm pronouncing it correctly. Especially Alex, Michael, and the students who helped us to learn how to solder, and actually everyone in this amazing Makeathon. Thank you very much for organizing it. We really enjoyed it so much. And thank you for being here.
Thank you. All right, up next on stage are the smartest buildings. Give them a warm applause. Oh, you forgot to...
Test 1, 2, 3.
Test.
Are you ready?
Hello, my name is Oskars, and I'm the team leader and also the designer.
Hello, my name is Sophie. I'm the documentator and did the presentation.
Yes, yeah.
My turn.
Yeah, sorry.
So our beautiful team is the team leader, of course, Oskars. We have the Bakery programmers, the two Alejandros and Jose. The database expert is Aaron, and the programming sensors Helena, and me with the documentation, Sophie. Sorry. Next stage, please. Thank you very much. Our objectives, our project is to save electricity, make things easier at the building, and make the building more greener with plants. Yes.
So our solution is we divided it between two projects, the Flower Power and the Home Assistant. The Flower Power is basically a small home garden that, and the Home Assistant is the Home Assistant is a way to make things comfortable at home and waste less electricity. And we combine it all together in one website. Okay.
Yeah, our story, or what we managed to achieve, is an almost functionary flower power system. We also managed to achieve sensor functionality for the building and all put it on the website to manage and observe. Next, please.
Next one.
Perfect.
Okay. So here are some pictures of us making the progress. We did a lot of brainstorming and coding, also with a database, and
yeah, it was fun to work on the project together. Yeah.
Here's a video. Yes, here is a video of the Home Assistant where it has some sensors. We don't need noise. Yes, thank you. Where there are some door sensors to check if there's a person coming in, and it automatically turns on the light. Also a temperature sensor. But in the future we would like to add also to be able to turn off the heater and the lights. And the next?
Yeah, the next one is the other project, Flower Power, where we can see on the top the lights and on the bottom there the sensors. Yeah.
And what she did there, she covered the light sensor with her hand, and the light turned automatically on, and after a little bit it automatically turns off because there's enough light around. And in the future we would also like to add a automatic watering system where it also waters the plant. Yes, there it turns off. Yes, here's
Again?
Sorry. Here's the website where it stores all the information. It's also a video.
It's a video. Okay.
Yes. Thank you. It stores all the information for the plants. You can activate one plant. It depends on what kind of plant you have it on the pot. And you can activate one, add one, another one. But in the future, we would like to also add a camera system where it detects the plant and applies all the information by itself. But right now, you can only do it manually. So I just say thank you.
That was our project. Thank you.
Thank you very much. Thank you very much. Up next on stage, we have the TSOS team. TSOS, where are you guys? One applause for TSOS. Is it in?
So let's start with TSOS. What is TSOS? TSOS is a trash sorting operating system. Where's the idea coming from? We found the number of half a ton waste which is produced by every European, I think, per lifetime. We were shocked by that amount of trash. And after reducing trash, I think sorting is the second best option. And so our idea was to build a conveyor belt where the trash is sorted. We had to do some limitations for the project, of course. So we focused us on wood, plastic, metal, which we can sort also in aluminium and steel, and glass. Yeah. And so we had to make a brainstorm in the beginning, and we split up our team into the robot and the PLC team. The PLC team selected and were testing the sensors. They programmed the PLC and also built up the sensors which we can connect to the conveyor belt. Then we had the robot team, which were programming the robot, building the whole conveyor belt from scratch, and also train the machine learning software by using the MVTech software for the sorting. Yeah. So our special feature from the conveyor belt was that we used industrial components like the PLC, which was from B&R, and also using the software from MVTech, the camera, thank you for that, and also connecting a Raspberry Pi, which I think is not an industrial component, but connecting it to the B&R PLC. I think that are our key facts. Sadly, we hadn't time to make a video, but it's still working downstairs. So if you want to see it working, you can come to our table. But we have amazing pictures from the media team. Between having fun, building something, and time pressure, I think that is a very good ending for our yeah, everything. Thank you.
Thank you. All right, so the first part is almost over. Well, you did some really nice prototypes. You used our material shop a lot in our 3D printing booth. I want to give a shout out to Quandaland, to Juliana, Isabina. Maybe you come on stage as well. Are you here? Yes. Please come here. So Jana and Sabina, they came not only here to help, but they had a full luggage with material. So thank you for your support. I hope you enjoyed it here. And yeah, thank you for joining us this year. All right. Yeah, we had some more people in the background helping. So there are some people from Wilhelmshaven who were there at the reception, always giving you fresh T-shirts, always welcoming you. So are the Wilhelmshaven girls, are you here or are you busy downstairs? Yes. Thank you so much. And then you had in the workshop, when it got to the dirty work, you had the Passau students helping you with that. I heard the Passau people want to come here now. So they're here. Thank you for showing people how to drill, showing people how not to hurt themselves. And thank you. And like we will do a short break now afterwards. So people in the live streaming area, you can switch rooms for the second part. And in the meantime, well, we will do a 5-minute break and continue at... Welcome to the second half of the final pitches. Please, everyone, take a seat. There are some seats left now here, so feel free to take those. All right. And we have a full block of Lawrence teams coming up. 3 teams took the Lawrence Industry Challenge, and we will start with the Green Transformers. Let's give them a warm applause. Green Transformers next on stage.
Okay, thank you.
You want to use?
Yeah, thanks. Hey, so hello, my name is Valentine, and I'm the team leader of the Green Transformers. And today I'm going to showcase, the presentation about the Lawrence Challenge. So, meet the team. Our team is made out of software developers and engineers. This is a water meter. The water meter is sensitive, it's breakable, and most of all, it's really fragile. Oh. Let's go one back. And this is his new bodyguard. It's not just a packaging, it's a security system, basically. But you might think, what is the problem? Well, the whole problem is...
So either you walk a bit closer to here, or we can do
sorry,
it
it was that one.
No, it's here.
Ah, okay. Water meters travel. They travel a lot. They go everywhere, but transport can be dangerous, as you can see. So not only the travel, but like I said, the transport can be very dangerous because all of the vibrations it will go past through. But even stacking the normal carton boxes can lead to damage and also like invisible actions. So here we introduce our smart box, the Lorenz. This box knows always where it is, if the product is in it, and yeah. The best thing of all, like the basic things, it's super robust. It will protect to all vibrations, and it fits all of the sized meters. It's not just strong, it's kind of social. It's social because they link so good. It's stackable by the top cylinders. It can fit up to 1,275 pieces per Euro pallet. And with our design, we save up to 64 kilograms of paper per pallet. Feels like Lego, to be honest. Takes a bit. But why is this smart? In our sliding hatch sits the tech compartment. With the tech compartment, like I said a bit earlier, we can always, Lorenz will always see where the product is. It has a vibration monitor, so it can warn beforehand. And with the sensor, we can see if the product is still in it. It's connected by Wi-Fi or Bluetooth. But what does this mean for Lorenz, though? For Lorenz, this means live tracking, early detection, and tackling problems before the delivery. Because they don't know it yet, but if it has an error and it will be installed, they only know it after it has been installed. So we can tackle it beforehand. They also have insight if the product has been removed from the package, and they can also monitor the product age, because yeah, you don't know if it's on a shelf, like how long is it there for. But why is it like really smart? Well, Lorenz lab will get an immediate notification if the vibrations are too loudly. They can take immediate actions for the product, and there will be no surprises left afterwards. But hey, it's just packaging, right? No, it protects, it monitors, it optimizes the logistics, it sends live data, and it will be robot controlled. We use the software from Math Labs to control the robot arm from eGoose, big thanks to eGoose. And yeah, we installed the gripper on it, 3D printed. Can lift it up, takes a bit, but it will work. We will speed it up the process. But you can see it works great. So yeah. Thank you.
Thank you very much. So, well, we have a few more Lorenz presentations coming up, but here you can see a lot of logos, and I really like how you use parts from all the sponsors there. We have eGoose and MathWorks as silver sponsors with us, bringing some really cool equipment, and MathWorks doing a workshop. I think that was the fullest one ever using the software. So please, eGoose and MathWorks, come on stage. All right, thank you guys from eGoose and MathWorks to have us, to join us this year again. And all right, and we have two more presentations from Lorenz coming up, so I'm looking forward to those. Up next on stage, the next team from Lorenz, it's called NXT Box. Welcome on stage. Da liegt noch eins.
Okay, after 4 days of really hard work, we are now very proud to show you our final product and how we tackled the Lorenz challenge here at the Makeathon. This is us. We're a team of 8 industrial engineers, and when we saw the Lorenz challenge, we instantly knew it was a match made in heaven. We quickly realized We quickly realized how well we can work together with the Lawrence team and how we can apply everything we learned in university in this real-life problem. Right now, the status quo is a very simple cardboard box to transport the water meters from the Lawrence headquarters to the technicians and from the technicians to the houses. It brings many problems. Because it's a one-time use, it's not part of the circular economy. It's discarded after usage. The meters are not very well secured in the boxes, so sometimes they arrive with faulties. It's not very trackable, so it's really hard to see where is which water meter. And all that combined, we set ourselves a challenge. We wanted to develop a reusable, modular, and digitally traceable transport container for residential water meters, replacing disposable packaging and enabling circular returns. We've defined this for ourselves to always come back to the bigger picture and never lose our focus.
All right, so I'm going to talk about our first idea. Here you can see our first prototype. You can see that there's 2 mounts on each side and a little bridge where the product sits on. So the bridges and the columns, they prevent the movement and especially the rotation, which is one of the biggest problems when transporting. And it stabilizes the water meter, and also this is fitting for all 3 versions of this product. And our final product, you can see it right here. You can take a look at it afterwards if you want to. So this is basically 10 of these boxes which I just showed you, and we tried to make them as logistically efficient as possible. So we took a holistic approach. We tried to make it include all the parameters that could affect the production of such a product. We tried to make it realistic and practical, so it's easy to handle. We had a big focus on the producibility and that it is cheap to mass produce. Also, we made it logistically efficient, so you can stack it upon each other, and also they fit perfectly on the Euro pallet. Also, it was important to us to not over-engineer it. So, for example, we didn't put any systems inside which need electricity or power in general, but we still put an RFID chip. We have a sensor which monitors if it was dropped, and also we were focusing on that the box can be integrated into the processes of Lawrence. You can see some of the pictures here.
Okay, now for the smart functions, we integrated an RFID tag. That's where you can see that on the side. It's just a little card that's clipped into the box from the outside. And then there is a video in a minute playing. The green box, it's that one here. It has an RFID scanner inside. In the future, this will be integrated into the conveyor belt at the Lawrence headquarters. So whenever one of the boxes passes, it scans the RFID card, and then it shows you all the information that is needed, such as is the box empty, how many meters are in there, what kind of meters are in there, and where this box is at the moment. Okay, so right now the card is being scanned, and then in the Google Sheets you can see the information that is stored on the card, and then on the other side the information can be changed and then scanned again, and then it's updated and automatically synchronized with the Google Sheets. And then for the technician as well, he or she has a pre-installed app on the phone. They can just go to the box, scan it with their phone, and then have similar information like the Lawrence team on the side here, such as how many meters are in the box, are they new, are they old, do they need to go back to Lawrence, where are they at the moment, and all the information that is in there can be changed and will automatically synchronized in the Google Sheets at the Lawrence headquarters. So you can see that here. There's the status that can be changed, the location, the quantity down there. And then once you click on apply, it will automatically update in the Lawrence headquarters.
All right, so for our key takeaways from this project, the first one and basically most important one was to not over-engineer it. It is supposed to be a simple product. It's supposed to be mass-produced in very high numbers, so we tried to make it as simple as possible. Also, it was important for us to spend enough time collecting ideas, not just instantly starting to construct or to program something, but to really think it through, have a good idea, and then start working on this. We structured our work very efficiently by dividing tasks. We had 2 task forces which had 2 different problems to solve. And also the previous problem is not always the best solution. We had some prototypes, some ideas which looked very nice or felt like they can do the best purpose, but oftentimes these are too expensive, too complicated. And also, to keep the big picture in mind, there's a lot of things to be considered when doing such a product. And so we try to always have the big vision of everything.
So we just wanted to say a big thank you to ITQ and the Makeathon, to all the team. It was really fun. We had lots of fun. We learned a lot. Thank you to the rest of our team up there. Thank you to the guys from the 7th semester supporting us. And very big thanks to Jochen also. Happy birthday. Thank you for taking us here.
Thank you very much. Up next on stage, we have Team Lawrence Rental Box. Welcome to the stage.
Okay, today I'm planning to tell some story about how we had a journey with our project. Its name is Renzelbox. But as you know, I mean, this is our group. As you know, all of this was already set, so I don't want to really recap all of this. We're actually another team that is working with Renzo, and our problem is just delivery of those water meters without any damage or without any harm of those. So those water meters actually have something inside, something precious. It's a coil, and this coil is very fragile. It has to be delivered in a very specific way, like so that's not damaged. Otherwise, it has to be recalibrated again and reprogrammed again. That's what we thought of Lawrence. And this is the image for this. Normally, they are individual boxes are being used for the transportation inside of the tin box, but we just took this as inspiration for now. And what do we want to achieve, actually? So we set our goal. Nika is a project leader, set a goal, sustainable packaging and durable protection. That's what we wanted to achieve at first. But moreover, we decided as a team to have something like smart tracking system and impact detection. We'll talk about it a bit later. So what is sustainable packaging? We wanted that our project to last a bit longer than one use, not only of a cardboard or anything else. So therefore we wanted to use a 3D printer and build something with it, some housing to transportation. This should reduce actually paper waste and make it more recyclable. Durable protection. This is one of the goals that is being set, so the transportation itself does not make any harm to the product. smart tracking system, we wanted to track also how or whether the product is being damaged or not. So therefore, we made smart tracking system with QR code. This refers to our website. We have a demo there, and in the website you can see like the status where it's written whether it's has been damaged or whatsoever happened to the project itself. Okay, smart detection. We've developed a small, tiny piece for this. With this smart detection, you can see whether it took an impact or like whether it was any excessive vibration to the box itself. Those are our prototypes that we made during the project. As you can see on the bottom corner here, this small green piece, it has some kind of a layer where it's getting pierced when something happened to the box due to the transportation. So one can open the box and already see if it needs to be calibrated or it needs to be programmed again. So this is our final design of. This is the final design of our product. We took an inspiration of. We took as a base actually the DIN box. So it is the box that is being used to transport the actual Lorentz voltmeters. And for this we made an in layer where you can put those holders that we designed later on to transport our voltmeters. Okay, now we're going to the short video of the app itself, and here we go. Now we need to start again. So basically, what you see, it is just an app that we developed, where you can scan with the QR code the upper part of the DN box, and it shows you how many boxes or like how many compartments are available inside of this box. And you can also through the website manually change the box ID, or better to say we'll just give it like box ID, and also we can see like the status whether it's being damaged. There are also some other additional information like the key that one needed to program maybe wirelessly, and yeah, that's all. Cool.
Thank you very much. So yeah, we had 3 teams thinking about how to transport the voltmeters in the future from the Lorentz channel. Please come on stage. Little Lorentz team, we are very happy to have you here this year again. So thank you for joining us again this year. We're always happy to have you here as a sponsor, and hopefully see you next time. All right, now it's time for the Beckhoff teams, and we start with Team FrigoPie. Where's Team FrigoPie? Let's give them a warm applause.
Number?
FrigoPie should be number 15. So what was the challenge? Maybe you can explain a bit what the Beckhoff challenge was.
All right, so our Beckhoff challenge, we have an idea, a challenge to create a machine to sort some type of trash. We throw with it a general bag of trash, and we can sort it via some categories of plastic, paper, metal to make the process of recycling more clean and more cleaner and ordered. So let's start with our presentation. I'm Daniel. I am the team leader of number 15, FrigoPie. So we have a problem in this society with the recycling stuff. So in order to recycle an object, a material, we need to sort it in categories, as I say, because if we mix up, for example, plastic and metal, we ended up getting a weird material which cannot be usable. So with the backup challenge, we created an idea and make a team to create the machine to make work this challenge and make it real. So yeah. So here we are a team of a few people here. We are from a lot of places of the island and the other island. So we divided this team in 3 sub-teams. So we are the machine learning team. So we decided to program and create a machine learning model to identify each material and sorted it with the logic of the machine that we created with our modeling and design team and also the handwork team. Without them, this project wouldn't be possible to create. So, okay, so in order to make a solution to this idea, we create a prototype which we sketched it a lot in paper. So what is the main idea of this machine? So we created a conveyor belt where we put it a lot of trash and with a webcam support connected to a Raspberry Pi. We scan each. So we connect in all the trash, we threw it into the conveyor belt, and with the Raspberry Pi and the laptop, we create a client/server connection where the Raspberry Pi sends an image to the laptop, and the laptop with the machine learning stuff, it recognizes the object and it sends back an answer. For example, it's a paper. So the conveyor belt will go forward and throw it the object inside of a container that we designed. Okay, so we have a video of a demonstration of how this works. So we have the conveyor belt with a piece of paper, and it recognizes it is a paper. It moves forward. We have 4 containers where the paper goes in. Yeah, well. Okay, so how this works is a machine learning model, and it sends the text, the order, to move each container left or right to match the conveyor belt way to throw it the object. Well, in this project we use some motors of IGOS and some drivers from IGOS. So thanks IGOS to provide us and teach us some stuff to make this possible. It has been a very hard project to do it. And yeah, we learned a lot of things. We learned how to program machine learning, trying it, and we learned how to solder and design some stuff and create a functional project, from zero, from scratch. Well, that's also so far our presentation for the day of today. So thanks Makeathon for hosting us here. See you soon.
Thank you very much. Up next on stage, we have Team Trashback.
Sorry. No.
Okay, so hello, we are Team Trashbag. And in the last 3 days, we built an automated waste sorting system for the Back-Off Challenge. So, first of all, this is our team. We are 13 students from 4 different universities and schools from Germany. And we have a background in mechanical, electrical, mechatronical, and paper process engineering. But no one in our team had previous knowledge in machine vision or PLC programming, which was a major part of our project. First of all, what is our project? We were faced with the problem of different kinds of waste which are mixed and how we can automatically sort them. This is a very common problem in waste management around the world. And we had some goals to achieve. So we wanted to transport the waste with a conveyor belt, automatically detect the trash type, and then also automatically sort them into the right container. And for this, as you can see, we used the trash from lunch. So just wooden fork, knife, some paper packaging, plastic packaging, and also metal caps. So different materials, which are all mixed. And we were fortunate enough to have Backhoff and MVTech to support us with components and software, and most importantly, knowledge. So at first we brainstormed a bit about what we could do, and we came up with this concept. So basically we have a conveyor belt which is also made by us, where the trash is transported along, and then we have one camera with a machine learning algorithm which automatically detects the trash type. And then it sends the information to the Backhoff PLC, which then controls the conveyor belt as well as the positioning of the trash containers. And for the trash containers, they are on one linear rail from EGOS, so we can easily move the containers. And it was also important for us that the containers themselves are easily exchangeable. So if they're full, we can just switch into an empty one.
This was the concept. And here we can see the video. We are first in the initializing phase, so you can see the movement of the axis with the containers. They switch to the end pose, and then we can see in the video that we can put trash on the conveyor belt, also here in live as well. It's recognized by the camera with the machine learning algorithm. And then it sorts, it slides the containers. As in the video you can see it. We have a few mechanical problems here, but it's working. We have a very high success rate. There was no item which was not detected. And we also implemented a stop button for emergency stop, so we cared about that as well. The challenges we solved and the learnings we got, the first of all was the implementation of the whole system via the Backhoff automation control. So we've got 2 motors which controls the conveyor belt and the slide. That all needs to be implemented in the automation control. Then we had a small issue with the MVTech software because it could not communicate via MQTT, so we have to recognize the image, write into a TXT file with a Python script to send the MQTT message. But you could see it worked. And other challenges we solved was a normal operation mode, emergency switch, and as well as mentioned the self-calibration of the axis. Now you can see it moves here as well. Yeah, the learnings. What did we learn? It was a wonderful time. It was a very, very cool project with a very cool group. Yeah, first of all, it was a programming with the Beckhoff PLC. Yeah, so interesting to dive deep into this concept. Yeah, the creation of the image recognition model and as well labeling and creating all these pictures. It was a very, very big task. Yeah, to work together as a team and to build this machine in such a short time. It was so cool, especially the moment when we just put everything together and it worked. We saw the conveyor belt moving, we saw the trash being sorted. Yeah, at this point, we really want to say thank you. Thank you to Carsten, to Michael from Beckhoff. It was so fun working with you. Yeah, and what we kept, it was basically the motto, keep it simple, try with the easy parts. We were always many steps ahead, wanted to integrate as much as we could, but it's always easier to start with the big things, with the small things, and then going over to the big things. Yeah, thank you to our sponsors, to the whole Makeathon team. It was a great project.
Nice. And you really did the live demo and it worked at the end, so? Yep. Nice. Okay, we have one more team from Beckhoff, the Smart Green Rubbish System. Round of applause. What did it?
Welcome and let me introduce the Smart Green Waste Task Force. At first we start with the engineering part of the team from Munich and Reutlingen. Then we come to our robotics, mechanics and mechatronics part of the team from Aalen. We come to our Switzer friends, the IT guys from St. Gallen, the computer science guys. And our hidden weapon, our 3D printing expert, who has his roots in India and based in Berlin. And all these expertise combines us to a heavy task force. And yeah, the question is, what problem will these task force tackle right now?
So with this little entry, we want to welcome you to our presentation about our Smart Green Rubbish System. First of all, we want to thank our sponsor Beckhoff for making this challenge possible. We learned many new things and we had a great time together. So what's the problem? In today's world, the sorting of the rubbish doesn't work very well, so the lack of awareness from the people who put the waste in the rubbish isn't always there, so nobody controls you if you put your aluminium in the PET, and that's a big problem also at the recycling place, where the recycling needs to be done with the right waste. First, our idea was to make an automatic waste detection system with a conveyor belt, as you can see here. However, this won't tackle the main source problem that we wanted to face.
Yeah, so what's the solution? Like you hear before, waste sorting is a heavy problem around the world, and our task force want to tackle the problem right before, right earlier at the source, at the bins, and not even later on the conveyor belts. So the solution was to build a smart bin which can automatically detect, decide, and direct the waste into the right bins. And yeah, that's the solution for our problem. And here are our concept, our first sketches, our first ideas and thoughts about the project. And as you can see, it goes really in a nice way. And here you can see our very first run this morning. And as you can see, it worked really pretty good, and we are very happy for that. And in the second run, we put 4 bins underneath, so it goes really in the right bin. And now you can see a live presentation on it.
So while you're watching the live presentation, I will talk about the features we included on our smart green rubbish system. So first of all, it contains some technical parts.
No.
Let's look at the live demo once more. Nice.
So because it contains many technical parts, there's also a high consumption of energy. So we made sure that we don't consume that much energy. So we built in a sensor which automatically detects when there is waste on the little platform you see there. And if there isn't any waste there, we can make sure that we turn the whole system off. And after there is waste detected on the platform, as you can see right now, the picture will be taken of it and it will be sent via an API to an external AI. We use that because it has already trained models there, and after we get the classification of the waste, as you can see on the little screen there, from paper up to PET and plastic, we get the classification, and with the classification we can then control the little robots, the little motors, which make the table turn and put the waste in the correct bin.
Yeah, and before we finish, I want to say a big thank you to everyone who make this happen. And first of all, for Rainer, Jonas, and everybody who is helping to make this happen here on an island. That's pretty cool for us. And kind of these events are pretty nice for young people, not only to make new friends, but also to learn new skills, to make new experience, to work on cool stuff, and become a better task force together. So thank you, thanks a lot, and also for the sponsors, for Backhoff, for the kitchen team, for the helpers, and for the crew, everybody in the background. Here are so many people running around, and look that everybody's working, so thanks a lot.
Thank you very much, guys. Okay, so lots of cool Backhoff prototypes. Please come on stage, Carsten from Backhoff, or who else is there from Backhoff? So I'm glad you're back this year. I'm very happy to have you, and thank you for joining us this year.
Thank you very much.
All right, so we continue with some Circuit teams, which is the next is the hydrogen excavator.
Right. So, this is actually, this team is not in this room right now, but they are watching us via the live stream, so they are watching all the other teams, and they are also, hi guys, in Germany. You might remember this guy, and some of you already saw this in the team presentations in between. So this is a project that started on the Makeathon 2024. So this was 2 years ago. You see, this is like more the prototype kind of tractor. But now we're a bit more advanced. So you see on the next slide, it already works. So here is our colleague in Germany trying out this nice excavator, and you already see they mounted the whole hydrogen fuel cell on the back. So this is now running completely electric, no diesel motor involved, no cables involved. This is running on hydrogen now with a big battery in between.
Yeah, talking about logistics is a bit difficult to bring it here, so they sent this video and did this in Germany with a team of about 20 students on the Hochschule Rhein-Waal in Kleve. Some of you are here, Carsten is here, for example, William is here. You're here, there, okay. So you started this 2 years ago. Thanks for supporting this challenge. In that at home, thanks for the support. Thomas Klimek is also involved, and the ITQ team from Duisburg here supported this challenge with Nico and the students. Ali, thank you so much for supporting this. Yeah, we will continue this as a lecture in the next few years, and hope to see more on this on the next Smart United Makeathon. Next team up is
Water Waste Monitor.
Water Waste Monitor.
Welcome on stage. Yeah, sure.
Here we go. So this is just our prototype coming in.
So yeah, hi. First of all, we're the Water Waste Monitor guys. Yeah, so this is our prototype. So I guess I'll start introducing ourselves. So we're from Germany, Iceland, and Gran Canaria, Spain, of course. First of all, why are we doing this project? You might think, when you go wash your hands or brush your teeth, you might start thinking, oh, it's just a bit of water, there are just some milliliters, or just a liter, it's nothing big. But if everybody thinks so, it adds up. So it's way more than just some milliliters. So first of all, we wanted to reduce unnecessary water consumption in our everyday life, and demonstrate how technology can support environmental protection, and also combine the environmental responsibility with the modern technology. So in conclusion, in the end, raise awareness about sustainable water usage. Yeah, so who are we again? Spain, Germany, and Iceland. Spain, Guillermo, Guazet, Alvaro, and in Germany, me, Sophia, Bennett, Ole, and Iceland, Ari, Peter, and Ingimar. Yeah.
So, how did we even do this? The hardware and software. We used an ESP32 for the communication with the sensors. We did use a Raspberry Pi where the website and all the stuff was hosted. We had ultrasonic sensors, and we've got a pump from Lorenz that they thankfully gave us, which was not listed on the store, but we've got it anyway. We've used MQTT, a database, and we've made our own little API, and then hosted a website, which you will see in the next few slides. So this is our prototype. I think you can see it right here. This is the website. I don't know how big it is. Yeah, it's fine. It will count the water liters usage and how many times you've activated it in that current day. You can reach it under water.local in the Makeathon network. If everything's okay, it should work without Wi-Fi. I don't think. No. Oh, it does. So now it's being added to the Wi-Fi, and the water counter is being increased. The water runs for 30 seconds, which is the recommended time of usage for a person who's washing their hands actually clean. And also it's just, I think, 3 to 5 liters which are being consumed. The water pressure isn't the biggest, but it's all right. It's all right.
Yes.
What do you meant?
Yes, our main goal was to implement it in school or different institutions, so that the administrators could monitor the water waste and see all this information on the website, and also maybe the pupils or the other persons who work or study in this specific institution could also see what's going on actually.
Yeah. So, a little in-depth analysis. We've used our ESP, just how I mentioned, with the sensor data, which is being transmitted to a Raspberry Pi, that then processes the data, adds it to the website, and adds the water counter. There's also a limit, which we thought of implementing a notification, like you'll use 50 liters today, calm down a bit. So the communication goes with MQTT, with the broker, and just normal, MQTT. So, our responsibilities, how did we do it? We have split ourselves into 5 little groups. We've had the hardware guys that assembled the cabinets and the pipes and went to a hardware store to get some stuff last minute. We had technical hardware, that was the sensors, the pumps, all that stuff. Then we have the server side, pretty basic. It was the back end, which the Icelandic guys did. Thank you to you. And now you can, exactly, thank you.
So,
what we learned today? Go with the flow. Okay, Sophia? So, we learned water waste is a real problem in today's society. We've also learned how to manage time correctly. A 3D printing design should not take 10 hours. Also, we managed to do problem solving, like a bit easier with our guys, and we've improved on that. And how to work in a group effectively and not have people sitting around doing nothing.
Yes. So there's always something to improve in the end, and that's also good because there's space for feedback. So I think the main problems that we had were like with the server or maybe some materials like the sink or a filter. We were very aspirational, like we had a lot of goals to do from the beginning, and like slowly you see that actually not everything that you plan is doable. So a server would have been nicer. I mean, to host a better server, like to have much more time to kind of structure it and host it. Yes, and like the sink, we actually painted it like with spray paint, but we could have also like used maybe some metal or aluminum. Yeah, so for the future, it's something we could improve. And also maybe even a filter, like if you can see, then it can maybe show you.
No, I don't think I can show them.
So
we've used Lorentz water meter, but it's in the bin right now. I don't want to make the floor wet, so...
the filter, we could use maybe a filter to filter like the water that has been used and kind of use it way more times than once. Yes.
Okay.
Exactly.
Thank you. So, thank you for your attention. Thank you, dear Makeathon. We had a very, very nice challenge here. It was very fun to work with all you guys, learn new things and make new friendships that probably will continue until the end of time. Hopefully, I guess. So, thank you very much. It was a very nice Makeathon.
Yep.
Thank you very much. Thank you, guys. All right, we have, last but not least, Softy is coming up next on stage. Welcome on stage. Just to be sure, is there any team who we missed? That's the Softies. No one else is...
Anyone presented?
No, okay. Just to be double-checked. Softies.
Hello, we're the Softies, and our project is a smart bin. Have you ever noticed how carelessly some people discard their trash? How sometimes they just throw everything in the general bin without even thinking about it? Maybe you did yesterday even in the carnival, where everything was filled to the brim. So a lot of recyclable materials end up in the general waste bin. We believe that this doesn't happen out of malice, but just out of laziness. People just don't want to carry around their trash everywhere, think about the material types, and search for the correct bin everywhere. So we believe that there isn't a really good consumer, easy consumer product that you can buy that easily recycles for you. So we came up with a bin that does the thinking for you. What do we mean by that? Well, it's a bin that automatically sorts trash into the correct bin. It's split into 4 compartments, with each section for different type of trash: plastic, paper, glass, and waste. We have a camera that detects the trash and activates motors that spin the bin inside to position the compartment to the correct spot, and then it pushes it inside. Each compartment, So how did we achieve this? We used MVTech's machine vision software and trained a deep learning model with it to detect the 4 different types of trash. And we ran it on a Raspberry Pi, so it uses very low energy. Then we use an ESP32 microcontroller that's connected to the motion sensor, and it's also connected to the motors. And we use that, and we use Bluetooth low energy to communicate with the Raspberry Pi. So the system isn't on all the time, so it only uses low energy. And yeah, a huge thank you to MVTech, which helped us a lot and gave us a license to their program. Thank you. So how does the process work? Well, when you place an item into the bin, the motion sensor is activated, the lights inside the bin turn on, a Bluetooth low energy signal is sent to the Raspberry Pi, then the Raspberry Pi turns on the camera, takes an image, and MVTech software analyzes it and tells us which material it is. It then sends a packet back to the ESP, which interprets it and moves the motors accordingly, and then pushes it into the correct bin. Unfortunately, we didn't finish the bin, but we had all the moving parts working. So we have the 4 different compartments that spin and push the trash in. Then we have MVTech software, which works and is highly accurate. And then we also have the communication between the Raspberry Pi and the ESP. The system is motion activated, and it's fully isolated and powered. And here you can see the system. So who are we? We're the Softies, and we couldn't have done this without this amazing team. We're a pretty software-focused team, so you can imagine that this project was challenging for us. We had to learn a lot of different things and new things for it, and that's maybe where the name comes from. Like I said, we had to learn a lot of different things for this project. We had to revisit older things that we learned like in the first years of school. We had to learn with the new equipment and industrial applications. And then we also had to communicate effectively and learn to work as a group. There's also came up a lot of different problems, and we had to like stop and focus on them and completely change our approach, which we had to do in the middle of the process. But we had a lot of fun, and there was a lot of pressure, but we had a lot of fun, and it was great meeting all these new people, and like the last team said, hopefully friendships for the rest of time. So thank you so much for the Makeathon and MVTech.
All right, so that was it with the technical teams. We did have one special team this year, though. You all have met them indirectly. So we have our special cooking team from BBS Wilhelmshaven. Please come on stage. So, really shout out making food for so many people. I saw a lot of happy faces eating. It was so nice food, and I guess even if it was a bit stressful, you made it. So. So I don't know, Philip, willst du was sagen noch? And we have a little something. We have a little something for you. So, Smart Green Island, Schürze, I don't know in English. So that's for you. And I think we have those prepared too. Ja, die ist nicht vorbereitet. Danke dir. Danke dir. Danke, danke. Vielen Dank. Danke, danke. Vielen Dank. Dankeschön. Vielen Dank. Guido. Vielen Dank, Philipp. So, you might want to take them on right away, and then we have a nice...
Sure. Anziehen.
So you can see in the picture in the background, we also had helps from some young people from Maspalomas from the south of Spain who also helped together. So we had a mixed team from Spain and from Germany. Unfortunately, they could not be here today, but you see in the background the really nice cooking team. So big applause once more. Come on.
Thank you so much for your nice feedback. Our service team got to know you way better than the cooks, but we gave the feedback further, so everybody is happy that you enjoyed our food and everything went accordingly well. We had our own problems to face, but everything worked out very fine in the end, and we are happy that you enjoyed our food and our service and had a good time while eating lunch and taking your breaks. Thank you very much.
All right. There were some other people in the background. And who do we continue with? All right. So I know a lot of the people from the ITQ team are already downstairs busy or cleaning up or making the material clean up already. But a big shout out to the ITQ team, to all my fellow colleagues, and to the Spanish team. I don't know, maybe who's here, you want to come to the front? Maybe Sandra Arnes, if you're here. So I want to say thank you to all of you, to all the professors, to all the sponsors, to everyone who made this possible somehow, to you for joining. That's the most important part. The Makeathon is for you young talents to enjoy technology, and please spread the word about this event, and I hope you enjoyed it. I hope we see us on the next Makeathon, and yeah, that's a big thank you from my side, from the ITQ team. Yeah.
Hello guys, we want to say also thank you from the students. If we had problems, you were there, you helped us to find a solution, and we are very thankful that without you it wouldn't be possible, and thanks for the helpers and for the organization, for the Orga team. Yeah, thank you very much, and a big applause.
All right, thank you so much. That's a lot we have to share. All right, so before we go down, I have some more housekeeping, so I think we are done here. Looking at today, so we are now at the end of the final presentations. And I have some little organizational stuff for the rest of the day. So we have to be out of the museum today at 3 sharp, and we need to clean up until then. So it would be nice if everyone tries to help us make this museum look nice again, because on Monday it's opening and it shouldn't look like it now. So first of all, your demonstrators, please disassemble them and give the good material back to our material booth. They will put the inventory. Bring tools back to the workshops and put all the chairs in columns and also in the workshop area, as well as the tables need to be folded also in the workshop area. So all the material that we need that is ready for transport goes into the workshop area, and of course all the food and all the glasses and so on put into the cafeteria. So it would be nice if everyone tries to help he or she can. And what else is there? Well, today we have pizza. I don't know if it has arrived yet, but it's going to be in the second floor then. And what else is there? Okay, no, that's the organization stuff. Okay, so just thank you from my side. I had a great year with you this time. I think Arnes has a little surprise for us, and then after that we will see you downstairs. Thank you.
Thank you, Jonas. I bring for you a little surprise, but before I will start, maybe I missed it. I would just to ask you again, how was the Makeathon? Wonderful. Thanks. I think definitely we should spread this positive vibe and amazing experience through all over the world to show up how we can change the world to a better world, especially by nowadays, and to show up how innovation is possible. So only with your voice, with your experience and the support of you all, we can just realize further Makeathons in the future. So at this point, I would like to thank my media team for their great job, especially Marina, Fidel, Jakob from Endless Media, and my team colleagues, Caroline and Elisa. Big applause to them. Thank you. And we can, yes.
No, we do, what? Like, before we look at what's coming, let's put all the sponsors that are here together once more here on stage, so we can have a group photo there as well. Please, okay. Once more, big applause for the sponsors. Nee, einfach damit hier kurz auf.
Sponsors?
So, geht ruhig, rutscht auf. So, thanks to these people, we had drinks, we had food, we had material. So at the end of the day, those are the sponsors that make it possible at the end of the day. So really big thanks for joining us, even if times are hard, to continue investing in education. That's really a really good thing, and we love to have you here.
Give them a really big applause, huh? Because it's not that easy to get them. Yeah, try it again. And as you see here on this overview, there is a lot of space in the upper level, yeah? And this would be very nice that some of you would go back where you were, yeah? Because actually, well, I think we live in a really crazy world, and I think education is the key. And if you don't understand this, then we have really a problem. Yeah? Because everything starts from the beginning, and education is the basis of everything. Yeah? And we saw here, we started with these little kids here, yeah? Not only the big kids, yeah? And therefore we had here the government. Today it was the Cabildo, the local government, and yesterday we had the government of the whole island, and we had a lot of very important guests in the Blue Saloon. You didn't see it, and we were really pushing hard in the background to bring it up. And I know I'm more or less talking to the wrong people here, but actually we have, you go home, I send already to all your presidents and CEOs a lot of videos and push at home because actually there is a lot of things to do, and therefore thank you very much that you were here, and please push harder.
Thank you. All right, and now back to Arnes and his final surprise before we leave for downstairs.
Thank you. But before I will start with the surprise, the last thing, we sent you already our feedback form, so please give us your feedback. That is very important for further events which we will realize. Thank you very much.
Is the tone on? Can we have audio?
Yeah, you like that. Make it like. Yeah, you like that. Make it like. Yeah, you like that. Make it like. Yeah, you like that.
Thank you very much. Thank to you all as well.
Thank you. Goodbye. Have a safe travel home.